Hi, I am Tammy and I do math for coffee, and this is the first video where I'm going to teach the second semester of Algebra 1. This is not like a regular class or anything like that. I'm just going to go over the big concepts in this class. So if you have to teach it to yourself to review or you are absent for a class period, this will help you get caught up. So day one, if in my class we would be talking about polynomials. We're going to start with polynomials. Usually an Algebra 1 class, second semester, will start with a review of exponents. If you need to see that, I have some videos for that as well. I have a whole playlist for exponents. For this, I'm going to just jump into polynomials. Let's define them. A monomial is a number, a variable, or a product of a number and variables. It's also called a term. This will make more sense when you see it. I just need to get some of these definitions out of the way. A polynomial is a general term used when the terms are added or subtracted. Let's take a look at this. All right, I have some polynomials here. Look at the first one, the number of terms. There is one term here, and the name of this polynomial based on the number of terms is monomial. There's only one term. The second one, 4x squared y, is a single term being added to another term, x cubed. There are two terms here. That means we are going to call this a binomial. Terms are terms are things that are multiplied together, but if you add or subtract them, that's why you get a polynomial. All right, here we have three terms. So this is called a trinomial. And for the last one, we have four terms. Each one is you're separated by adding or subtracting. There are some books that are going to name that, but usually once you get past trinomial, we're just going to call that a polynomial. The polynomial is the general name, and you can obviously write these as long as you want them to be. All right, let's talk about the degree of a monomial. Now, all of these are one terms. These are all monomials. The degree is determined by the sum of the exponents of the variables. So in the first one, 7x squared, there's one variable. It has an exponent of 2, so this is of degree 2. There are two exponents in this monomial. The x has an exponent of 2 and the y has an exponent of 3. So this monomial has a degree of 2 plus 3, which is 5. Now this one might seem like it's 5. You have a 2 here and a 3 here, but you do have a z, and it has an exponent. It is 1. So that we actually have a degree of 6 on this one. The degree of a polynomial, so if you have a bunch of terms added or subtracted, the largest degree of any of the terms. Let me show you what that looks like. All right, here is a polynomial. It's just 4, and we don't really think of those as polynomials, but it does have a degree. Because it is multiplied times something, x to the 0 power equals 1. So if you think of it that way, this one has degree of 0. And this is called a constant because it's just a number. This x to the 0 thing, I know you have to kind of contrive that, but that's why it does have a degree of 0. The x being multiplied times the 4, you don't see an exponent, so it's actually a 1. So this has degree of 1. And the name based on the degree, they might have some new words here for you. This is linear. You're already in Algebra 1 first semester. We worked with these a lot. We solved equations. We did graphing of line. We did not graph things that had exponents on them. So when you have an exponent, you don't get a straight line. But when you just have a degree of 1, you will get a straight line when you graph it. That's why it's called linear. All right, this guy. This monomial inside this it's a trinomial. Inside this one has a degree of 2 because it is 2 on the exponent. This one only have a 1. So the highest degree between all of these terms would be 2. So that is why the whole polynomial has degree of 2. We have a word for that. It's called quadratic. And in second semester, you'll be working with more quadratic functions that have squared terms in them. All right, the degree here is going to be 3 because the 2 and the 1 added together. It doesn't matter if they're the same exponent. Obviously, if they were the same exponent, we would combine these. It's the whichever term in the polynomial has the highest degree, that is the degree of the whole polynomial. When it's got a degree of 3, we call that a cubic. And this guy right here will have degree of 4. This would have degree of 1. This would also have degree of 1. 4 is bigger than all of those. And we're just going to call that 4th degree. Again, there are some books that have names for that, but in general, once we get past the degree of 3, we're just going to call it 4th degree, 5th degree, 6th degree, because that's just less confusing. Let's practice some. Name each polynomial. You may not understand exactly what I mean by that. Let me show you. So we're looking at this term. It doesn't have a string of things added or subtracted. So this is a monomial and it is of degree 2. So we're going to call that a quadratic monomial. This polynomial, the degree is also, the highest degree is 2. So it's quadratic, but it has 2 terms. So this would be a quadratic binomial. This one is also going to be quadratic. 2 is the highest one. You're going to work with a lot of quadratics this semester, which is why I'm leaning on this. But how many terms does it have? We got 1, 2, 3. So that's a quadratic trinomial. K doesn't have an exponent written here, so the exponent is 1. That makes this linear. But it has 2 terms, so this is a linear binomial, linear meaning line. Standard form of a polynomial. We're going to write the term. In order to get it into standard form, you have to write the terms in descending order based on their degree. So you just look at the exponents and you put the largest exponent first. So for this first guy, I have 7k squared, set 2k, negative 8. The 7k squared would have to come first. 7k squared, then the 2k, then the negative 8. The constants are at the end. We're going in descending order of exponents. So this one would be the x to the 6th would have to come first, and the 6x to the 5th second. Not the coefficients in front, but the exponents. 6, 5. Usually it's easier to put everything in standard form for what we're doing. When we work with polynomials, it's just easier to see what's going on if you have them written in order. Now, those are some basic concepts of polynomials. After that, in your class, they'll teach you how to add and subtract polynomials, so we're going to do that as well. Adding and subtracting polynomials is about putting together things that are in like terms. So this 6x squared comes from x squared over here plus the 5x squared. So I got the 6x squared. And x plus 8x is 7x. So when you're just adding, you're basically combining like terms. That doesn't even really get that tricky. Where this whole thing gets a little tricky is when we end up subtracting or have negatives involved. So let's take a look at this problem. All right, I'm going to go in with the cubic ones first, because I'm going to write this in standard form. Negative 8x cubed plus 4x cubed. Then we're going to put the 4x squared with the negative 7x squared. I'm putting a plus in between all of these terms. This is a plus in between. And we're going to add that to what? Oh, I don't have any other x's over here. So this is just going to be negative 8x. And I have a constant 7. All right. This is what I would be probably doing in my head, but you can write it out as well. All right, let's combine these things and see what we get. That negative 8x cubed and the 4x cubed is going to be a negative 4x cubed, plus 4x squared minus 7x squared. That's going to be negative 3x squared, plus negative 8x. I'll clean up these signs in a second, plus 7. All right, now let's clean up the signs. When you have a plus negative, that's the same thing as a subtraction. I have negative 4x cubed minus 3x squared minus 8x plus 7. And that's our final answer. Okay, this one's a little different because there's a subtraction sign in between. I'll show you how I handled that. All right, start by copying the first binomial just as it is. Now, what I'm going to do is I'm going to change this to a plus, but change all the signs of everything that comes after it, a plus minus kind of thing. So instead of subtracting 8x, I'll be adding a negative 8x. Instead of subtracting a positive 3x, I'll be adding a negative 3x squared. Now we're going to put together our like terms. So this one is going to be x squared minus 3x squared, and then we'll add, because I changed that to a plus, but because I adjusted all the signs of everything that came after it, it's going to work. Mathematically, it's the same. So I have a 2x positive minus 8x. Combining these like terms, we end up with 1x squared minus 3x squared is a negative 2x squared plus, this is going to be 2 minus 8, that's negative 6x. We have a plus minus here, so I need to combine those into a subtraction. And that's our answer. Let's do it again. Copy the first trinomial as is. Then you have this negative, and you are going to change this to a plus, but everything afterwards, the signs flip. It's going to become a negative 6x cubed. A negative becomes a positive 7, and a negative plus becomes a minus 8x. Combining like terms, we'll start with the cubes. I have a positive x cubed minus 6x cubed. That's going to give me a negative 5x cubed. There are no x squared, so the next thing would be the x's. Negative 7x minus 8x, that gives me a negative 15x. And 2 plus 7 is 9. That one went a little faster this time, you see? That's our final answer. Perimeter of a rectangle is just knowing you have to add up all the sides. So that is what perimeter means. So let's add up all the x's. I have a 4x here, an x here, another 4x, and another x. That's 5x and another 5x. So I have 10x. Negative 1 plus 2 is positive 1. Positive 1 minus 1 is 0, and 0 plus 2 is a plus 2. And we're finished with that. Now we're going to move on to multiplying polynomials. All right, now since we're multiplying, you are going to need to know your exponent rules. And if you are multiplying two things that have the same base, you add their exponents. If you can't see the exponent, it's actually a 1. So I have 2x cubed times x. That's going to be 2x to the 4th. If you don't remember the rules, let's just reason it out. We have x cubed, that's 3x's multiplied together, and then you have another x. So that's giving me 4x's being multiplied together, x to the 4th. All right, 3 times 4 is 12, and x times x is x squared. There you go. That's a monomial times a monomial. What if you do a monomial times a binomial? I have 2 of these, and this is going to look like distributive property because that's what it is. 4x times 8x. Well, 4 times 8 is 32, and x times x is x squared. And then 4x times a negative 1 will be minus 4x. So there's our answer. 8x squared times x, well, it would be 8, and then it would be x cubed because they'll end up being 3 x's multiplying together here. And then we're going to take that 8x squared and multiply it times a negative 7. 8 times negative 7 is negative 56. And then it would be, should be x squared. I left that off. I'll have to fix that. There it is. Okay, we're good to go. All right, now a monomial times a trinomial. You can do distributive property again, but I want to show you a little technique we're going to start using, and this is going to be the boxes. I take the 8x squared, I write it out here, and I put the 7x squared minus 5x plus 8 on the top, and then we're just going to multiply each thing and put the answer in the boxes. So 8 times 7 is going to be 56. X squared times x squared is going to be x to the 4th power. 8x squared minus 5x, that's going to be negative 40x cubed. 8 times 8 is 64. X squared times, there's no other x there, so the x squared just comes along for the ride. So this is your answer. You just have to write it as a polynomial outside of the boxes. The boxes are what we're going to use going forward because it helps you keep track of something that's a little bit more complicated. Not the only way to do it, just the one that I've used in class that people seem to understand the best. So we're going to do it here. All right, now we have a binomial times a binomial. So we take the top binomial. Doesn't matter which one you put on top. Just write one of them on top, and the other one goes down the side. Now, there's another way to do this called FOIL, which I'll talk about in a minute, but I wanted you to do the boxes first. I wanted to show that. Now you multiply, just kind of like a multiplication table if you've ever used one of those. This times this goes, and the answer goes in the box. So I have 7x times x, that's going to be 7x squared. Now I'm going to take this 7x times the 8. That's going to be 56x. Jumping down to the bottom row, I have 1, and I'm going to multiply that times x, so that just gives me a 1x. You don't have to write the 1. I'm doing that just to be super clear. And then you take the 1 times the 8, that goes here. Now, you're going to get 7x squared, d6x, and 1x. You can write it out. I'm going to just add them from the boxes. That's going to be 57x. And then the 8 comes along. So this is our final answer. All right, let's do it again, but this time the problem's going to have some negatives in it, just so you can see how this all works. We have 7x minus 6. I'll put it on the top. I could put it on the side. It doesn't matter. I just always do things the same way with math, so I can catch errors. All right, we have 7x times x. That's going to be 7x squared. Negative 6 times x is negative 6x. Negative 2 times 7x is negative 14x, and negative 2 times negative 6 is a positive 12. All right, we have one squared term, that's 7x squared. We're going to have to combine these x's, and that's going to be a negative 20x, and then we have the plus 12. All right, that's using the boxes. I'm going to do the same problem again, doing it the way that you might see it in your class. I'm just using a different method that they teach called FOIL. This is how I learned it. I like it. It's a little bit like distributive property. FOIL stands for first, which means you're going to multiply the first terms. That would be the 7x times the x. We'll do that here. And we'll put the answer there. 7x times x is 7x squared. Then we're going to do O, which stands for outer. And that would be the outside terms. That would be the 7x and the negative 2. 7x times negative 2 is negative 14. So I'm going to go plus a negative 14x. Inner, not belly buttons, the inside term right here, negative 6 and x. So that's going to be plus minus 6x. You should look familiar. We just did it. It's just a different way to organize your work. And last, which would be the negative 6 and the negative 2. So that's going to get us the positive 12. And then when you combine these, there's your 7x squared, there's your negative 20x, and there's your 12. No, I don't think anybody's going to care that much which method you use, if you use boxes or if you use FOIL. I know that later on in the course, I'm going to bring the boxes back. I like to have people familiar with those. And I also like boxes for more complicated problems like this one. It's a binomial times a trinomial. Now here, it isn't like you can just pick where you want to put stuff because you have to go by how many boxes you have. So the trinomial with 3 terms has to go along the top because I have 3 boxes this way. And then we're going to do the x minus 5 down the side. And we do the multiplication. Again, not the only way you could do it. I just think it's very compact and super efficient. I dig it. So x times 2x squared is 2x cubed. X times 2x is 2x squared. And x times negative 4 is negative 4x. Moving down to the bottom row, negative 5 times 2x squared is negative 10x squared. Negative 5 times 2x is a negative 10x. And negative 5 times negative 4 is a positive 20. Now, combining all this stuff is going to be a little bit trickier. I know I have 1 cubic term right here, but I have 2 x squared terms. I have 2 x terms, and then I have 1 constant. Just looking at this before I even start. So now let's write the answer. 2x cubed first, because that has the highest degree. Combine your x squareds, that has to come next. So you have a positive 2x and a minus 10x, that's going to be a minus 8x squared. Combine your x terms, that's going to be a minus 14x. And then you have a plus 20. Other ways to do this, I just think this takes up the least amount of paper, which is why I think you're going to like it too. All right, let's make it one more level complicated, and that's a trinomial times a trinomial, and so you're going to end up with a 3 by 3 box. And I just think these are fun when you do them with the boxes. I don't know what it says about my personality that I'm really into boxes. You judge. Okay, so we have 4x squared times 5x squared. That's going to be 20x to the 4th. 4x squared times 5x is 20x cubed. 4x squared times 3 is 12x squared. 5x times 5x squared is 25x cubed. 5x times 5x is 25x squared, and 5x times 3 is 15x. Negative 6 times 5x squared is negative 30x squared. Negative 6 times 5x is negative 30x. And negative 6 times 3 is negative 18. All right, we got some work to do to combine. There's only 1/4 term. That's going to be the first one that we write because it's in the highest, it has the highest degree. We've got a couple of cubes. Let's put those together. A 20 and a 25 is 45, so that's 45x cubed. I actually have 3 x squared terms that need to be combined. And when you do all of that, negative 30 plus 25 plus 12, I worked it out ahead of time. It's going to be 7x squared. We have 2 x terms, and I've run out of space. We'll go down to the bottom here, 15x and negative 18. Long problem, huh? But this is your polynomial. It has 1, 2, 3, 4, 5 terms, and it is of degree 4. Degree 4 polynomial is the answer here. Let's talk about some special cases. Stuff like this, they're going to want you to memorize. And in all things math, I think memorizing is a lot easier once you see the pattern and can figure out what's going on. Your brain will grab onto it better. So let's just do this. I have 4x plus 3 squared. That is a binomial squared. It means it's being multiplied times itself. So let's do that with the boxes and we'll see what we get. 4x times 4x is 16x squared. 4x times 3 is 12x. 3 times 4x is still 12x. and 3 times 3 is 9. The answer here, when you combine those middle boxes, is going to be 16x squared plus 24x plus 9. Now, what happens if we change one of the signs? So instead of just squaring 4x plus 3, we're going to take it times 4x minus 3. Watch what happens. 4x times 4x, you get 16x squared, and 4x times 3, you still get 12x. The first line is the same. But now we move to the part where it says negative 3, and this is going to change some signs. So we end up with negative 12x in this box, and over here we end up with a negative 9. Well, look what's going to happen here. When the signs are different, you're going to end up with the same value, but one of them is going to be negative. That's going to cancel out. So your final answer is 16x squared minus 9. We're going to do it again. I want you to see the pattern. When we square the exact same binomial, this is going to be 64x squared. This is going to be negative 8x. There's a minus here, so maybe it's a little different. We'll see. Negative 1 times 8x is also minus 8x. And negative 1 times negative 1 is a positive 1. When you write this out, these two boxes are not going to cancel out. You're going to have to combine them. Negative 8x and another negative 8x is a negative 16x, and you get a plus 1. 8x times 8x is 64x squared. 8x times negative 1 is minus 8x. Positive 1 times 8x is a positive 8x. Ooh, 1 and times negative 1 is just a negative 1. You can see what's going to happen here. And we end up with that. Notice, this is not the same thing squared. It looks the same, but the signs are different. And then you have these boxes canceling each other out in the middle. Over here, this is one thing squared. Things don't cancel out. We're going to just do it one more time. X plus 5 squared. And if you're getting frustrated because you already know the answer ahead of time, bravo, you're with me. X times x is x squared. If you don't yet, that's fine. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. Notice nothing's canceling out. We end up with x squared plus 10x plus 25. It might be easier to see the pattern on this one. Do you notice the x is getting squared? The last term is this 5 times 5, but there's a term in the middle that's actually 5 times x doubled. All right, let's do it again. And I'm pretty sure you can know the answer to this one before I do it. But you know what? If you ever forget, you know how to do it. X times x is x squared. X times 5 is 5x. Nobody cares if you do a little extra work. There we go. There's our boxes. And the middle boxes are going to cancel out. And you end up with x squared minus 25. So when you look in a textbook or your teacher gives you notes in class, this will probably be the special case as formulas. We're going to work them out so you can see what they are. They use a's and b's. A times a is a squared. A times b is ab. B times a is also a times b. And b times b is b squared. So you end up with a squared plus 2ab plus b squared. This is the general formula for when you are taking a binomial and squaring it. This is what they're going to tell you to memorize. If you don't memorize it, you can at least multiply it out with boxes, and that's fine. This one's a little easier for people to memorize, is when you have the same numbers but the different signs in the middle. We get the a squared, we get the positive ab, we get the negative ab, and we get the b squared. We know these boxes are going to cancel out. So you end up with a squared minus b squared. Now be super duper careful, because once you learn a little bit, this is when things start to go wrong. People will start doing this with this, and they will say that a plus b squared equals a squared plus b squared. They completely forget there's a middle term. If everything is positive or everything is negative, there will be a middle term. The only time the boxes cancel out is if you've got opposite signs like this. The next lesson starts with factoring. I'll give you an answer, and you are going to break it up back into the multiplication problem that it started with. See you then. Thanks for watching. Bye.